Hello and welcome. My name is Dr. Trajan Head, and I'm the product manager for Prism at GraphStats Software. In this video, I'm going to give you a brief tour of Prism and introduce you to a number of basic features and concepts within the software that'll help you get up and running with your own data to perform some basic analyses and generate some graphs. So let's get started. When you first start Prism, the first thing you're going to see is the welcome dialog. From the welcome dialog, you can choose to create either a new data table and graph, or to open an existing file and work with that. If you're going to create a new data table and graph, it's important to understand the 8 different types of data tables that Prism uses. 2 easy ways that you can do that is to check out our video on the 8 types of data tables, or you can use a tutorial data set. Each of the data tables in Prism comes preloaded with a set of tutorial data that you can use to understand how the tables are structured and how to perform different analyses within those tables. To access the tutorial data sets for any of the data tables, simply select the data table that you'd like to work with, and then choose the option Start with Sample Data to follow a tutorial. We're going to start by using the tutorial dataset for an ordinary one-way ANOVA under the column data table. Clicking Create brings up the project file and shows you the tutorial data. However, like other tutorial datasets, this only shows you the data. You'll still need to perform the analysis yourself so you can learn how to better navigate Prism. These datasets will also provide instructions that cover the basic structure of how the data are organized, the goals of the tutorial, and some of brief instructions for how to achieve those goals, which are typically to perform the analysis of interest, in this case, a one-way ANOVA. These instructions are shown on a floating note on the datasheet, and you can add your own floating notes by clicking on the floating notes button in the sheet section of the toolbar. Other important sections of the toolbar include the file section, where you can create new projects or save your work. In the sheet section, in addition to creating floating notes, you can highlight sheets, create new sheets, or delete existing sheets. The analysis section we'll come back to in just a moment. The draw, write, and text sections are mainly for customizing your graphs and layouts. And finally, there are a number of sections that allow you to export, print, and share your work. In addition to the toolbar on top, the other very important section of a Prism project is the Navigator panel on the left. In the Navigator, all of the sheets of your Prism project file are organized by whether they are a data table, a project info sheet, an analysis results sheet, a graph, or a layout. And within each of these sections, you can organize the order of the sheets simply by clicking and dragging. It's worth noting that any sheet that is linked to the actively selected sheet, such as graphs or analysis results generated from a data table, will appear bold in the Navigator panel. Below the Navigator is the Family panel. This provides another way of viewing linked sheets. Only sheets that are linked to the sheet that's currently selected in the Navigator will be shown in the Family panel, and this panel will update when you select new sheets in the Navigator. So that's the basic layout of a Prism project file. Let's now look at how to perform an analysis. In the toolbar, let's click the Analyze button, select One-Way ANOVA, and click OK. In the dialog that appears under the very first tab of Experimental Design, you'll be able to make any necessary changes to the analysis based on your own experiment. For example, whether your data were matched or paired, or whether you can assume that your data were sampled from a Gaussian distribution. Other options for the analysis can be found in the various tabs of the Parameters dialog. For example, the main test of an ANOVA looks at 3 or more groups and compares their means or averages. However, the main test doesn't report any information on the means or averages of any given pair of groups. To do that, we need to select Multiple Comparisons and define the type of multiple comparisons we'd like to make. We'll select Compare the mean of each column with the mean of every other column and click OK. When we click OK, we'll be taken to the main analysis results sheet. Within these results, you can find important information such as the F-statistic, the calculated p-value for the test, a summary of significance, and other important information for the test, such as the ANOVA table. However, this sheet doesn't provide the information on the multiple comparisons that we identified in the Analysis Parameters dialog. Those results are found on a separate sheet. Each analysis that generates more than one sheet of results will display those results as a separate tab. Here you can see the tab for multiple comparisons can be found next to the sheet for ANOVA results. When we click on the Multiple Comparisons tab, we'll be shown the results of the comparisons between specific pairs of groups that we identified in the Parameters dialog, including the difference between their averages, the 95% confidence interval of that difference, the calculated p-value for the difference, as well as a summary of significance. In addition, we'll have the test details that indicate the average of each group, as well as the sample size for each specific group. Importantly, when you're looking at an analysis results sheet, a new option will have appeared in the toolbar. The Interpret button will take you to an analysis checklist online that helps ensure that you made the right choice of analysis and will explain the underlying assumptions of the analysis that you chose. Finally, let's look at the graph of our data by clicking on the graph sheet for one-way ANOVA in the Navigator panel. The first time you navigate to a graph, the Change Graph dialog will appear. This allows you to select the kind of graph you'd like to use for your data and shows a range of available styles based on the type of data table your data are in. For our data that come from a column data table, we can choose to show our data as a simple bar chart, as a box and whisker chart, or a violin plot, or simply as a scatter plot with various options for how to show the mean and error or median and error as you choose. When you click OK, your graph will be shown. However, if you change your mind later, you can always go back to the Change Graph dialog by clicking the button in the Change section of the toolbar. Many other options for graph customization can also be found in the Change section of the toolbar, including the Format Axes dialog, which allows you to customize the axes as well as the frame and origin, grid lines on the graph, or customize tick marks as well as titles and fonts of your graph. The Format Graph dialog provides customization of the datasets, including the symbols, colors, shapes, line weights, and other appearance options for your graph. Here you can select the dataset you want to change. You can select the appearance, how the line and error are shown, the color of the symbols, the shape and size of the symbols, the style of the error bars, and many, many other options. The Format Graph dialog also lets you determine which datasets will be shown on your graph and in which order. For example, on this tab, you have the option of adding, replacing, or removing datasets on your graph, and determining the order that they're shown simply by clicking and dragging them within this window. In a future video, I'll cover some of the various ways that your graphs can be customized so that you can emphasize what's most important about your data in your graph. Once you have your graph saved the way you like it, you can export it using the Export button in the toolbar. In this dialog, you can assign a name and a file location to save your file, choose the type of file that you'd like to export, such as a bitmap, a JPEG, or a TIFF, select the resolution that you'd like your file to be saved at, the size of your graph, and also whether you want your background to be white or clear, and your choice of color space including RGB, CMYK, or grayscale. So that's it. Those are some of the fundamental aspects of Prism that you can use to start working with your own experimental data. There are tons of other types of analyses, graphs, and features throughout Prism, and one of the best ways to explore those is through the use of the tutorial datasets. However, the basics always stay the same as you go from data to analysis to results to generating and customizing your own graphs. Have a great day, and let me know if there are any features in Prism that you'd like to see explained in future videos. Thanks for watching.